Hi Year 11, I'm just going to go over the 2022 PEM preliminary exam so you can help yourselves with these answers to get ready for your prelim exam coming up in the next couple of weeks. Okay, so I'm just going to speak through each of them and just remember there's different ways to get to answers in maths. So the way that I show you right now is not the only way to find the answer, okay? Alright, so the first one says, if Jai can pack 36 boxes per hour, how many can she pack in 20 minutes? So a couple different ways to work this one out, but I'm going to show you the unitary method so that you can use it in other questions as well. So we would go 36 boxes per hour. Okay, if we want to take this to minutes, because we've got 20 minutes, I'm going to change it to 36 boxes per 60 minutes. And because we only want 20 minutes, I'm going to divide 60 by 3. And remember, you have to do it to both sides. So I'll end up with 20 minutes on this side because 60 divided by 3 is 20. And 36 divided by 3 will give me 12. So I know that he can do 12 boxes in 20 minutes. So our answer is C. Okay, choose the correct solution to the following equation. So obviously we need to solve this equation. So 3x plus 1, I'll just rewrite it, 2, 5 minus x. So we've got brackets on both sides and pronumerals on both sides. So we're just going to expand that. 3 times x becomes 3x. 3 times positive 1 becomes positive 3. Equals 2 times 5 becomes 10. And 2 times negative x becomes negative 2x. Now we've got positive pronumerals on both sides, so we need to put them on the one side. So I'm going to add 2x there and add 2x here, and I'm going to rewrite it. So 3x plus 2x becomes 5x plus 3 equals, I haven't done anything to my 10, and minus 2x plus 2x becomes 0, so I can get rid of that. Now I've got a two-step equation, so I'm going to move the 3 to the other side by subtracting it. And we end up with 5x equals 7. I'm going to divide by 5 to get my x on its own, and I'll end up with 7 over 5. Now, that's not one of my answers, so I'm going to use my calculator and do a division. 7 divided by 5 comes out at 1.4, and I can see that answer there at D. Evaluate the following equation for D. So if my equation is S equals D over T, it says I'm going to substitute in S is 60 kilometers, so S equals 60, and T equals 3.5. So there's a couple of different ways you can do this. You can just substitute them into the equation that they've given you there, or if you know your little triangle here for, distance, speed and time, you could also just rearrange it for D. We know that if you do distance, you're going to do speed times time. So I'll do both solutions for you, and you can choose which method would work better for you. So if we use the original one they've given us, S equals D over T, we'd substitute in 60 for S. D is what we're looking for, and our T is 3.5. We just have a one-step equation here, so we'd multiply across at 3.5. And we'd end up with D equals 60 times 3.5, and that comes out at 210. The other way you could do it is using your D equals S times T, and straight away we'd just go 60 times 3.5. That's if you remember how to use your triangle. So 210 is our answer there. Okay, how many tablespoons of 15 mils of medicine are in a medicine bottle with a capacity of 0.9 litres? First thing I'm going to notice is that I've got mils and litres. So I'm going to turn my 0.9 litres into mils, which is going to give me 900 mils because there's 1,000 mils in 1 litre. So 1,000 mils equals 1 litre. So now I want to know how many tablespoons of 15 mils. So I'm just going to take my 900 and divide it by 15, and that will give me 60. So D is going to be our answer there. Okay, the XPT leaves Sydney Central Railway Station at 7:40 every weekday morning and arrives in Melbourne Southern Cross Station at 6:30 at night. How many hours is the trip? Well, first of all, we need to recognise that says 6:30. So we're going to go 7:40 a.m. a.m. to 6:30 p.m. It's many different ways you can do this. I'm just going to do a quick timeline. So if I'm at 7:40 a.m., I'm going to add 20 minutes, which takes me to 8 a.m. I'm then going to add 8, 9, 10, 11, 12. I'm going to add 4 hours to take me to 12 p.m. Then I can add 6 hours to take me to 6 p.m. and 30 minutes to take me to 6:30 p.m. Okay, so then I add all those together. I've got 4 hours and 6 hours. So 4 hours and 6 hours gives me 10 hours. And then I've got 20 minutes and 30 minutes, which gives me 50 minutes. So 10 hours and 50 minutes, and we'd be looking at D as our answer. Okay, a 1 litre container of almond milk has the following nutritional information. So you can see all our info there. The value of X, so we're looking at X over here, and the number of grams of fat in 100 mils, and Y, the number of kilojoules in 1 cup of almond milk should be. Okay, so we need to work both of those out. So the first thing I want to see here is this is the average per 100 mil. This is the average per quantity size. So I need my serving size. You can see up here my serving size is 250 mils. So for this one I need to do a little bit of work. So let's do X first. So X grams. So if this is 100 grams, this is 6.1 grams. So our 6.1 grams is for 1 serve, and we know that our 1 serve is 250 mil. Okay, so if we've got 1 serve at 250 mil, I want it to go over to this side to 100 grams. So I really want this one to be 100 grams over here. Okay, so what I'm going to do here is I'm going to divide by 2.5, because 250 divided by 2.5 will give me 100, and I'm going to divide by 2.5 here. So 6.1 divided by 2.5 will give me 2.44 grams. So I'm going to say that X equals 2.44. Now let's do the same for Y. So Y, now Y is on the other side. So Y is on the the per serve side. So we're going to go for Y kilojoules. We've got, we've got 154 kilojoules per 100. So if I have 154 per 100, then I want this side to be 250, don't I? Because it's per serve this time. So I'm going to times by 2.5. So both sides times by 2.5, and I end up with 385 kilojoules on this side for Y. So Y should equal 385 kJ. So now let's look for that answer. So I've got 2.44, 385. So our answer is B. Fair bit of working out there for 1 mark. Okay, the interquartile range of the ages of people who attended a car show last Sunday listed below is. Okay, so we need to find the interquartile range. The first thing I'm going to notice is this is not in order. So we need to put the numbers in order first. So I'll just quickly do that. Okay, let's see, how many numbers do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'll just double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Beautiful. So to find our interquartile range, we need to find our Q2 first, which is our middle number. So we're going to go 1, 2, 3, 4, 5. If we've got 10, we should have 5 on either side. So that's our Q2. If we have 5 on either side, then we can find a nice middle one there. So that's my Q1. And over here, that's my Q3. Okay, so my interquartile range, remember that is Q3 minus Q1. So I'm going to have 60 minus 29, and that will give me 31. So answer B. A motorbike costs $3,190, including 10% GST. What is the price before GST? Okay, so let's remember that GST is 10%. Our pre-GST price is 100%, and with GST, price is 110%. So if it tells me that I've got $3,190 including GST, this is going to be my 110%. Now there's 2 ways you can do this. You can either take it down to 1% and then times it back up to 100% to find your pre-GST price, or you can just take it from 110 to 100%. So that's the way I'm going to do it here. So what's 110 divided by to get 100? Well, we would divide it by 1.1. Okay, and if we divide both sides by 1.1, 100 divided by 1.1 will give me, 110 divided by 1.1 will give me 100%, and 3,190 divided by 1.1 will give me 2,900. Now, if you can't remember to do it that way, do it this way. So if you have 3,190, we know is 110%, divide by 110, okay, and we get 1%. So 3190 divided by 110 gives me 29. And then I'm going to times that by 100 to find 100%. And that will give me my 2,900. Okay, so you can use that method as well. All right, use the trapezoidal rule twice to find the area of the field below. So the trapezoidal rule, remember, is on your formula sheet, and it looks like this. So it says area approximately equal to H over 2 dF plus dL. Okay, so remembering that your H is your perpendicular height, the side across from your curve. Sorry, I apologize. So that should be my height there, because remember they're asking us to do twice. Okay, so we can do it separately. Then this one, for the first one, will be my DF and my DL. So let's write that one out. So 16 over 2 times by 48 plus 58. So that's my first one. My second one, this is still going to be my height. Now this is going to be my DF and this will be my DL. So I'm going to go plus 16 over 2 times by 58 plus 63. Okay, now put that into your calculator. You might want to do it into sections because sometimes it's easy to make a mistake, but you should come out at 1816, which will give you the answer of C. Okay, let's have a look at the next one. Theo is driving 80 kilometres an hour in outback Australia when a kangaroo jumps across the road in front of him and stops. What is Theo's reaction distance if his reaction time is 1.4 seconds? So our reaction distance is the distance travelled during our reaction time. So this is a little bit tricky. So we need to go, if we're going 80 kilometres per hour, now our reaction time is in seconds. So we actually need to change this to meters per second first, because you're not going to drive kilometers in 1.4 seconds. So we need to change this to meters per second. So let's do that first. So we can change 80 kilometers to meters pretty easy. So 1 kilometer has 1,000, or sorry, I should put equals there, has 1,000 meters. Okay, so 80,000 kilometers, we would times that by 1,000 and we get 80,000 meters per hour. Now, we need to change our hours to seconds, okay? So because we're changing the second part of the rate, we have to do it to both sides. Now, when we're going from hours to seconds, okay, I should put a line there, hours to seconds. So we would then divide our hour by 60, and that would get us to minutes. And then we're going to divide that by 60, which will get us to seconds, okay? So divide by 60, divide by 60. So I'm going to write it on both sides. So divide by 60, divide by 60. So I know when I divide an hour by 60, I get to minutes, and I divide it by 60 again, I get to seconds. And if I take 80,000 and I divide it by 60 and divide it by 60 again, I get to 22.2 meters. Now that 2 is repeater. Now, the next part of this, so I've taken this into the right measurement now, meters per second. So our reaction time, so reaction distance is our speed times our reaction time. Okay, so speed times time. So our distance is going to be, our reaction distance is going to be our speed, 22.2, times by our reaction time, which was 1.4 seconds. Okay, when you multiply that, you'll come out with 31.11, and there's a couple of decimals there. So you can see that is answer A. A fair bit of working out for that one, but it's a good one to know because you might even get it as a short answer question. Okay, if finance is available on the purchase of a vehicle worth $21,400 with $3,000 deposit and monthly repayments of $380 over 5 years, the total amount paid for the car would be. Okay, so let's see what we're paying for the car. Well, first off, we're paying $3,000 deposit, so we're paying $3,000. Then we're going to be paying monthly repayments of $380 over 5 years. So that means for 5 years, every month, we're paying $380. So that's our years, our month, and our cost. Okay, so we multiply those and we get 22,800, but we have to add on to that our $3,000 deposit, okay, because we've already paid that. So we end up paying $25,800, which is answer D. Okay, residents in a certain town are surveyed on when they would vote in an upcoming election according to age. Their responses are recorded below. How many residents voted? Okay, so we just need to do some totals here and just double check. So 50 plus 150 is 200. 150 plus 240 is 390, and then we should be able to just add these two across and down and get the same number. So 200 plus 320 gives me 520, and 130 plus 390, 520 as well. So that's answer A. Okay, so that's it for multiple choice. Let's go on to our short answers, our short answer questions. Okay, use the simple interest formula I equals PRN to find the number of years it takes for an investment of $2,500 to earn $525 in interest at 3% per annum. Okay, these are the ones where you need to go, right, we're using simple interest. Here's some money, here's some money, here's an interest rate. What am I looking for? Find the number of years. So I always do this one, I equals P, R and N, and take out all the information. So I know that I'm looking for the number of years, so that's my N. I have an investment of $2,500, so that's my principal. I earn $525 in interest, so that's $525, and it's at 3% per annum, so 0.03. I can now put that all into my formula. I equals P times R times N. So my I is 525, my P is 2,500, my R is 0.03, and I don't know what N is at the moment. First thing I'm going to do is simplify this part here. 2,500 times 0.03, which will give me 75. And I'm going to times that by n because I still don't know what n is. This becomes a one-step equation. I'm just going to divide this side by 75, divide this side by 75. 575 divided by 75 gives me 7. And then I'm left with n on this side. So n will equal 7 years. Okay. Okay, then it says construct a graph to represent the simple interest I earned in dollars for n years for values of n from 0 to 8. Now, that can be a little bit confusing, but basically what they're saying is that we're going to go n years down here. Okay, so we're going from 0 to 8 years, and this is our interest up the y value. So let's grab a little equation and we can just do a table, nice and easy. So our equation is I equals PRN, but we know what the P and the R are. We just worked that out. So P times R back up here is 75. So we end up with I equals 75N. Now we can draw a little table for this for the 8 years if you want to make it so that it's correct, or if you work out the first and the last, so we know that at 0, anyway, let's just do this and then I'll show you what you can do to make it a bit easier. So if we go 0 years, 1 year, 2 years, 3 years, 4 years, 5, 6, 7, and they want 8 years. I haven't left myself much room in there, but let's have a look. So if we do 0 years, so we're going to substitute 0 in for the n. 75 times 0 is 0. So basically they're saying for every year we invest, we get $75. Okay, so for 1 year we get $75. For 2 years we get 150. 3 years we get 225. 4 years is 300. Now all of this is unnecessary to draw your line. I'm going to show you what is necessary to draw your line, but I wanted to just show you what they were asking you to do. So 5, 25 and 600. So you can see here for every year we invest, we get an extra $75. Now to draw this line, you really only need the 0 and the 0 and the last one, which is 8 and 600. So let's do that. So if we have a point on here that's at 0, 0, and then we go to the 8th year, and I'm going to scroll up to where it says $600. That's there. And we just need to draw a line that joins those two with a ruler, making sure it's straight. And that is your I equals 75N. Okay, so you just need to be able to get this part, your equation. And if you can find the first and the last point, then you can just draw the line to join in between. Okay. All right, question 14. Ali works in a cardboard factory. He has been asked to make a box for a customer as shown below in the following the dimensions. So let's put the dimensions on. A is 1.5, 1.5. B is 2, 2. H is 1.4. And L is 3. Okay. Ali works out the length of the slant side, so that would be this one here, of the trapezium using his diagram. Use Pythagoras to find the length of S. Okay, so that's finding these sides here, I think. Oh yeah, they're equal, so it's one of those two sides. Okay, so we're looking for S, so we're going to be using Pythagoras' theorem. It's asked you to use that, so you have to. Now, we want to remember that Pythagoras' theorem is c squared equals a squared plus b squared. And remember that this one is your hypotenuse. So in this case, we are actually looking for the hypotenuse because we're looking for S. We've got a H here. We know that H is 1.4 because they gave us that information. So we're now going to substitute this stuff in. So we're going to go S squared, our hypotenuse squared, equals our two sides, 1.4 squared plus 0.25 squared. then we've got S squared equals 2.0225. Now that is not our answer because we've still got S squared there. We need to make sure that we square root our answer. So square root both sides, and S is going to come out at 1.42. There are decimals and they didn't ask you to round it to anything in particular. So you could write 1.42 or 1.4, and we're looking at meters for S. I'm going to go with 1.42. Hopefully, well, we'll make sure in your test that it tells you what to round it to. For Ali to work out how much cardboard is needed, he needs to know the surface area of the box. Find the surface area. There's not a lot of room here to do that, but we're going to work through. So if we're going to work out the surface area, we need to find out this side here, which is a trapezium, and times it by 2 because we have a front and a back trapezium. Then we have a rectangle here, a rectangle here, a rectangle on the other side there, and then we also have the base rectangle as well. So we've got 2 trapeziums and 4 rectangles. So let's go ahead and work those out. So I'm going to do the front and the back first. Now, if you can see this quite well, you can do this all in one equation. I generally do it all separately, so that's how I'm going to show you now. So the front and the back is my trapezium, and I'm going to remember that a trapezium is, I think it's on your formula sheet. Let's have a look. If we go to your formula sheet, do we have a trapezium? Yes, we have a trapezium here. So you can see this one here is your trapezium. Okay, but obviously you have to remember what parts it corresponds with. So let's go back here. So I'm just going to write H, oops, wrong one. H over 2 is my trapezium A plus B. Now I've got 2 of these, so my end answer would be times by 2. So let's do that. My H in my trapezium is my perpendicular height, so H is 1.4 over 2 times by my A plus B, and I can see A and B is 1.5 and 2, so 1.5 plus 2, and all of that is going to times by 2 because I have 2 trapeziums. So when I work that out, I end up with 4.9 meters squared for my front and back. Now for my rectangles, so there's a little trick for your rectangles if you want to use it. Every rectangle is going to be by the depth of your prism because that's all 3 meters across. Then you could note that every side of your rectangle is going to be one side of your trapezium. So this is my first one. So this one here is going to be 3 times. Now we worked out that the slant side was 1.42, so 1.42. This one at the top is going to be 3 times 1.5. The one on the base, if we go across like that, is going to be 3 times 2. So I have 3 times 2. And then we have the one on the other side, which is going to be the same, which is going to be the same as our 3 times 1.42. So we've got our 4 rectangles. So I'm just going to write each of them out. I've got 3 times 1.42, 3 times 1.5, 3 times 1.42, and 3 times 2. So we just make sure that you've got all 4 of them. So we end up with 4.26, 4.5, 4.26, and 6. Now, surface area is obviously going to be adding all of those together. So 4.9 plus 4.26 plus 4.26 plus 4.5 plus 6, and we get a total of 23.92 meters squared. Okay. Then it says how much will it cost to the nearest dollar? Okay, to the nearest dollar is what we're rounding to. If cardboard is 33 cents, now as soon as I see that I go 0.73 per square meter. So if we have 23.92 square meters and it's 0.73 cents per square meter, we end up with 17.4616, and it says to the nearest dollar, so we would write $17. Okay, big question. Let's go to the next one. Okay, perform the following calculations and round your answer to 3 significant figures. So obviously you have to put this into your calculator. Now, each of you will have a different button on your calculator. You might have one that says EXP, or you will have one that says times 10 to the X. Now, remember that those two numbers calculate that whole part there. Okay, so you would just put it in as one number. So for this one, you would go 3.2, and then you would press your times 10 to the X, 9 divided by 2.3, press your times 10 to the X, 7 equals. Okay, once you put that in, you should end up with 139.1304348. Now, if you do that, and this is only worth 1 mark, you will not get that 1 mark, okay? Because you need to round this to 3 significant figures. So remember, your significant figures start at your first non-zero digit, so 1, and then we count across to 3. So your answer should be 139. Okay, this next one has a bit of information, so we'll need to read it. The body mass index is used an international measure for health and fitness for adults. The formula for BMI is D equals M over H squared, where M is a person's mass, so M is the mass in kilograms, and H is their height in meters. A 156 meter tall 80-year-old woman has been losing weight. The doctor measures her weight as 44.9 kilograms. So calculate the woman's BMI. So first of all, we're going to take those bits of information. So her height is 1.56 meters and her mass is 44.9 kilograms. So now we're going to use our formula. D equals, what did they say? M over H2. M over H squared, I should say. So it ends up being M 44.9 over H 1.56 squared. Now be careful how you put this in your calculator. Make sure you check it more than once, and you should come out at 18.45 as her BMI. Now it says, is the woman now underweight? So obviously we have to use our guide here. And if we have a look, she's 44.9 kilos, so she's going to be just about here. And then 1.6 meters in height, 1.56, so 5'6" is going to be about there. And if we measure those up, then she's obviously in the underweight. So is the woman now underweight? Yes, she is. Okay, question 17. A pot of soup is removed from the stovetop and placed in the cool room. The temperature is measured straight after placing it in the cool room as 100 degrees Celsius. Its temperature decreases according to this graph below. So always read your graph. Time in hours, temperature in degrees Celsius. Okay, state the gradient and the y-intercept of the line. Okay, so the y-intercept is always the easier one. So the y-intercept is where we cross over. So we started at 100 degrees Celsius. Okay, so that's our y-intercept. Then our gradient. So remember, the gradient is our m, and that is our rise over run. So the first thing I would note here is that I have a negative line. We're going down. So I know that I'm going to have a negative line. So I'm going to put my negative there straight away. Then I'm going to look for my rise over run. So here we can just use the triangle that they've given us. So you can see that we're rising from 0 to 100 and we're running from 0 to 5. So it's going to be 100 over 5. So we'll end up with negative 20 gradient. Okay, the next question says, what is the temperature of the soup after 3 hours? So let's have a look at the soup. after 3 hours. So all we have to do is go to the 3 hours, go over to the soup. Nice and easy one. It tells us that it's 40 degrees. So write 40 degrees Celsius. When you have a nice easy one like that, make sure you put the measurement in there because you might get marked down for not having the measurement. Approximately how long will it take for the soup to be at a temperature of 50 degrees Celsius for serving? So we could use this. We can go across 50. Now it says approximately. If it says approximately, you don't have to use a formula. You can just use your graph. So let's go across. We reckon 50 is probably about there. I'm going to get a straight line and go down here. I have a feeling it's going to be about 2.5 hours. My line's not perfect there, but if you have a look, if we go down here, I think, let me just get rid of that line. I've gone over a little bit. Oh, it keeps joining with the other bit. Let's try again. Okay, so we're looking at 2.5 hours, I reckon there. 2.5 hours. Okay. Let's go to question 18. A random sample of students were surveyed at University of Vincennes on the number of times they ate red meat that week. The results are shown in the table. Okay, so this is our frequency. This is how many times it happened, and this is how many times they ate red meat. How many students were surveyed? Well, that would be our total of our frequency. So total of frequency. So add all of those up and we end up with 90 students. Okay. What was the most likely times a week that they had eaten red meat? So most likely we know is our mode. So if you look for your mode, where are we looking? Excuse me. So which one's got the most? 20? Okay, but 20 is not our answer, is it? We want 3. So our mode in this case is 3. Now the last question says find the relative frequency. Now, first off, we need to remember what that is. So relative frequency, remember, is the frequency over the total number of students. So for this one, it says find the relative frequency of a student eating red meat 4 times a week. So if we go up here and we look at 4, how many are there? There's 18. So there's 18 students that eat it 4 times a week out of a total of 90 students. Okay, don't forget, we always need to simplify, so we'd end up with 1 over 5. How do you simplify? Put it in your calculator and press equals. 18 over 90, press equals, you get 1 over 5, or you might even get a decimal or 0.2. Either one would be correct. Okay, we have a field that a surveyor drew, the land survey below. So let's have a look. They're going to ask us some questions. We have some triangles and I can see a trapezium in the middle there. So let's have a look at what they're asking us. Find the length of DC correct to 1 decimal place. So where's DC? So DC is across here. So with these ones, I always take out my information. So first off, I'm going to draw my little triangle here. I know that this is D, this is C, this is what I'm looking for. So what other information do I have here? I can see that this part of D is 15 and this part across here is 39. So I'm going to put that in there, 15 and 39. So to find out DC, I'm going to be looking for Pythagoras' theorem because it is a right angle triangle. I am looking for my hypotenuse, so I'm going to be using the addition method. So x squared equals 15 squared plus 39 squared. So x squared will give me 1746. Don't forget we need to find the square root of both sides. So x will give me 41.8. Okay, now generally these surveys are in metres. They haven't stated that, but we'll just put a metres on there. So I now know that this one here is 41.8 metres. All right, the next part of this question says find the area of the field. So let's have a look at what we have here to work out what we need to find. So we've got one nice big triangle on this side, so I can just find the area of this. Then I've got this triangle here, which we just took out. We can find the area of that. Have another triangle down here. And then I can see in the middle here, I have two parallel sides. So I have a trapezium in there. Okay, so we're gonna find three triangles and a trapezium. So let's go down here. They haven't given us a huge amount of room, but there's some space underneath. Now you did not have to draw each of these. I'm going to draw them all so you can see what I'm doing, but in the exam you would just need to do the working out for each of them. Okay, so I'm going to do DEA first. So D, E and A. And remember, for our triangle we just need a perpendicular height and a base. So here my perpendicular height is 29. Now you'll notice that my base has lots of numbers. So it has 15 to there. Then it has 32 to there. Then this little bit in the middle here is 20. And then this bottom bit is 27. So that means my base must be 15 plus 32 plus 20 plus 27. Okay, and my base comes out at 94. So for this one, the area would be a half times 94 times 29. And that will give me 1363. So this one here is 1363. Okay, let's do our DC triangle. So we drew that one before. So we've got 15 and 39. Remember, you're always looking for that right angle. So this one would be a half times 15 times 39. And for that one we get 292.5. Then I'm going to do the bottom triangle. So this one here, I'm going to take this one out. Now this one's 35 across, but we've got to remember that it's 20 and 27, so it's 47 down. So 47 and 35, and look for that right angle in there, so it's those two numbers. So half times 47 times 35, and we get 822.5. So the last one we need to do is going to be this trapezium. Okay, so let's draw the trapezium, find our parts that we need, and we can use our formula to solve that one. Okay, so we've got 32 here, 39 there, 35 there, and that's all we need, isn't it? Okay, so let's remember our trapezium, our A and B are our parallel sides. So that means that we've got A here, B here, and our perpendicular height to both of those parallel sides will be our height. So for our trapezium, we're going to have a half times our A plus B, 39 plus 35 times by 32, our height, okay? And that comes out at 1184. So our total area will be all of these added together. So 1363 plus 1184 plus our other two triangles, 292.5 plus 822.5, and we end up with a total of 3662 meters squared. Okay, again, you don't have to do all of that drawing, but you do have to show your working out. So you would need to show this part, this part, this part, this part, and then show that you've added them together. Okay? All right, question 20. Let's have a look here. A chef randomly chooses 3 eggs from a dozen. So I'm just going to highlight a couple of things on this one. So I've got 3 eggs out of 12, because I know a dozen is 12, to make an omelette. 2 of the eggs in the carton are rotten. What is the probability that the chef has chosen 2 good eggs and 1 rotten egg? Now this one, there's probably multiple ways to do this, but I'm going to use my common sense with this one. If I am picking 3 eggs, okay, so I've got my first egg, my second egg, and my third egg. It tells me 2 of the eggs in the carton are rotten. So I know that rotten rotten eggs are 2 out of 12. Good eggs are 10 out of 12. Okay, so that's the first part I need to know. Then it says, what is the probability that the chef has chosen 2 good eggs and 1 rotten egg? So if you're taking the eggs out, there's only really 3 ways you can do that. You could go good egg, rotten egg. Good egg, rotten egg, good egg. Rotten egg, good egg, good egg. So that's pretty much your only choice of getting 2 goods and a rotten. Now you have to remember that once you take an egg out, you're not going to put it in. So the first time you take one out, it's going to be out of 12. Then one's gone, so now it's out of 11. And now another one's gone, so now it's out of 10. Now we could have drawn a tree diagram for this, but it would be massive. Okay, so this is why we're just going to use our understanding of our probability to work this one out. So let's have a look. We now need to work out the probability of each of these things happening. So if I take a good egg out first, okay, I'm taking 1 good egg out of 12, okay? But how many chances do I have to get a good egg out? I have 10. So I've got 10 out of 12 chances to get a good egg. Then I have another good egg, but I've already taken a good egg out, so I've only got 9 left. And this time it's out of 11. Now I'm taking a rotten egg out. Now there's still 2 rotten eggs in there because I haven't taken one out. So I've got 2 chances out of only 10 eggs now to get a rotten egg. So if I multiply those 3, I get 3 chances out of 22 to get a rotten egg. Sorry, 2 good eggs and a rotten egg. Let's do it again. So if I take a good egg out first, I've got 10 chances out of 12. If I take a rotten egg out next, I've got 2 chances out of 11. And then if I take a good egg, now remember I've already taken one out, so I've only got 9 left and out of 10 eggs. So if we multiply all of those across, I get 3 out of 22. Now for the last one, I've got a rotten egg first. So I've got 2 chances out of 12. Then I'm taking a good egg. I haven't taken one out, so I have 10 out of 11. And then I have taken one out, so I've got 9 out of 10 for a good egg left. And again, that becomes 3 out of 22. So the final part of this is you've got to add all of those probabilities together. Okay? And we end up with 9 out of 22 as our probability. Now, like I said, there are other ways to answer that question as well. But that one is how I would answer that question. Okay, question 21. The pool shop owners are charged a peak rate of $25.134 cents per kilowatt hour and an off-peak rate of 13.189 cents per kilowatt hour for usage between 10 p.m. and 7 a.m. They use their 2,800 watt. Now, as soon as I see that, I'm going to go 2800 divided by 1,000. So I get 2.8 kilowatts because this is always going to be in kilowatts. Pool pump for 3.5 hours per day after 10 p.m. Okay, so we know that if we're doing after 10 p.m, we're using the off-peak rate. 6 days a week when the shop closes. How much will their quarterly 12-week bill be for the pool pump alone? Wow, okay, lots of bits in this one. So first of all, we know we're after 10 p.m, so we're using the off-peak rate. So our cost is 13.189 cents. Then let's find the next part. We're doing our 2,800 watts, which we now know is 2.8 watts. Kilowatts, sorry. So we're going to go times 2.8 kilowatts. Then it tells us for 3.5 hours per day. So times 3.5 per day for 6 days a week. So times 6 days a week and for 12 weeks, this one here. So we're going to go times 12. So here we have our cost. we have our energy, we have our hours, we have, well, we'll change energy to kilowatts so you can see what we're doing. So kilowatts, hours, days, and weeks. So I'm just going to do it all in one calculation. Okay, so multiply all of those and we end up with 9306.1584. Remember, now this is in cents, so we need to divide that by 100 and round it to 2 decimal points because we're talking about money. So we get $93.06. Now, you don't have to do it all in one go, but when there's not too many conversions to do, it's okay to do it all in one go if you want to. Okay, question 22. So Joe holds 7 red cards and 3 blue cards in his hand. May chooses one card from his hand and places it in her hand. She then chooses another card from Joe's hand. Complete the missing probabilities on the diagram below. Well, remember that our probabilities on each branches have to add to 1. So here, he's got 7 red cards. She's got 3 blue cards. So we have 10 cards altogether. So 10 is going to be on the bottom the first time. 7 red, 3 blue. So we're just filling those out and they have to equal to 1. Now, when she takes the card, she places it in her hand. So the second time she takes a card, he now only has 9 cards in his hand. And that's going to be for everything on that side on the second card. So just put all your 9s there. Now, we can work it out. There's 7 red, 3 blue. So if we take a red out, there's only 6 reds left. So 6 out of 9 chance to get another red. If a red is taken out, we still have 3 blues left. And then you're just going to double check. Does 6 over 9 plus 3 over 9 make 1? Yes, it does. Okay, down here we have blue. So they've taken a blue out. So if we pick a red next, there's still 7 reds in there. So we have 7 out of 9 reds. If we've taken 1 blue out, so we've taken 1 away from 3, so we have 2 blues left. So just double check, 7 over 9 and 2 over 9 equals 1. Okay, so that's the rest of the diagram. Then it says, what is the probability that she has chosen 2 cards of the same colour? Well, there's 2 ways to do that. So we have the probability of getting a red and a red, plus the probability of getting a blue and a blue. So let's work out those probabilities and add them together. So if we're doing a red and a red, we're going to go along here. So we've got red and red. So for that one, it would be 7 over 10 multiplied by 6 over 9 plus a blue and a blue. So if we went blue and blue, so we'll go blue here and blue down here. So then that would be 3 over 10 times by 2 over 9. Okay, so put that in your calculator and you should come out with the probability of 8 over 15. Okay, question 23. An influencer earns 6 cents from her promoter for every like she gets on her site. If a particular week her site is liked 123,409 times, how much did she earn that week? So 6 cents, so we'll go 0.06, that's our 6 cents, times by her likes, 123,409. So for that week, she would get $7,404.54. She must pay 2.3% of her earnings to the company whose product she is promoting that week. How much does she have to pay the company? All right, so if we're paying 2.3%, we will go 0.023 multiplied by the amount, $7,404.54. So when we multiply that, she will need to pay $170.30 to the company. If she worked 52 hours that week preparing, recording, and blogging, how much did she earn per hour? Well, first of all, we have to take away what she paid to the company. So she earned $7,404.54, but she had to pay $170.30 to the company. She will get $7,234.24. Now they're saying she worked 52 hours, so we would divide that by 52, and that will tell us what she gets per hour. And she gets $139.12 per hour. Or just remember when you're working with money that it's 2 decimal places. Okay, we have a time question here. So there's 2 clocks. Use the above clocks to find which city which city is ahead in time and by how many hours it is ahead of the other. Well, you can see that one says Friday PM, one says Saturday PM. So you can see Katoomba is in front because obviously Saturday is in front of Friday. So we need to work out by how far. So if we're looking at New York is 9:22 PM on Friday. And we need to get to 12:22 on Saturday. So we're going to go 9:22 plus 12 hours will take us to 9:22 a.m. Now we're on Saturday. And we want to get to 12:22 p.m. So 9, 10, 11, 12. So we're going to add 3 more hours. And we get to 12:22 p.m. on Saturday. So we would write our answer here that Katoomba is ahead of New York by 15 hours. What day and time will it be in Katoomba when it is Friday 12 midnight in New York? Okay, so if it's New York and it's Friday 12 midnight, so AM. And then we want Katoomba. So between the two of them, it's 15 hours difference. And Katoomba is ahead, so we need to plus 15 hours. Okay, so I'm going to plus 12 hours first. So if I go Friday 12 a.m. plus 12 hours is going to take me to Saturday 12 p.m. And then I want to plus 3 more hours because I need 15. So plus 3 hours will take me to 3 p.m. on Saturday in Katoomba. Okay. Ming is single and works part-time for Woolies while studying at university. She's paid the casual rate of $21.16 an hour, and she works 20 hours a week for 44 weeks of the year. How much does she earn before tax for the year? So we're just going to take her pay rate, $21.16, multiply it by how many hours she works, and then multiply it by 44 weeks of the year. So if we multiply all of those, we end up with $18,620.80. Now, it says down here, Min has $250 in deductions for the financial year. How much will Min pay in tax? Okay, so we've got a couple of steps we need to do. First off, let's take her number, $18,620.80. So we're going to do $18,620.80. The first thing we need to do is find her taxable income. Okay, her taxable income is the amount that she pays tax on. So that's how much she's earned, but she had $250 in deductions. So we need to take that away because we don't pay tax on the deductions. So she's got $1,800 $18,370.80. This is her taxable income. So she's going to pay tax on this amount. So which tax rate are we looking at? We're looking at this one here because she's just over the 18,000. So when you're using the tax table, follow what it says. It says 19 cents, so 0.19 for each dollar over 18,000. So we're going to times by 18,370.80, take away the 18,200, which is the second part of our tax table. So we're going to calculate that. So basically anything over 18,200, she has to pay 19 cents for every dollar. So it works out, when you put it in your calculator, to $32.45. According to the information from the Medicare website below, does she have to pay the Medicare levy? Well, it says here, in 2020-2021, you do not have to pay the Medicare levy if you are single and your taxable income is equal to or less than $23,226. Blah, 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 blah. So she actually does not have to pay because, one, she is single, and two, her tax was way less than that. So you can just write, no, she does not. So she does not have to pay the Medicare levy. Okay, turning over. Just a note there, if she did have to pay the Medicare levy, just know that the Medicare levy is charged on the taxable income. So I'm going to put a note here. If Medicare levy, I could help if I could spell. Medicare levy is charged. It is calculated on the taxable, income amount. So for her, that taxable income amount would be the $18,370.80. Okay, so just if you have to do that in one of your questions. Okay, let's look at 26. The length of 40 leaves taken from plants of a certain species is shown in this table below. Find the mean leaf length and find the median. Okay, so remember when we do the mean of a class, so these groups over here, to be able to do that, we need a class center. So we need to find the class center of each of these. Remember, to find the class center, we add the group numbers together. So 25 plus 29 and divide by 2. So this one would give us 27. Then this one would be 30 plus 34 divided by 2, which would give us 32. And we keep going. 37, 42, 47, 52, 57. Now, to find the mean here on our frequency table, we find our f of x column. So that means our frequency times our class center times by our score. So we're going to do 2 times 27, which gives me 54. 4 times 32, 128. 7 times 37, 259. 10 times 42, 420. 8 times 47, 376. 6 times 52 is 312. 3 times 57 is 171. Now, if we total our f of x column, that will give us our total of all of our scores. So 1720. Then if we total our frequency column, this will give us our total of our number of scores, 40. So when we're finding the mean from a frequency table, we can use our sum of f of x over the sum of our frequency. So for this one, it would be 1,720 divided by the number of our scores, 40, and our answer would come out at 43 millimeters. So the mean leaf length is 43 millimeters. Now they've asked us to find the median. Well, we know that we've got 40 scores. So if we take 40 and we divide that by 2, we get 20. So our middle scores are going to be down the middle between the 20th and the 21st scores. So we need to go back to our frequency. Now, the easiest way to do this is to add them up like a cumulative frequency and work out where the 20th and the 21st scores lie. So here I'm looking at our frequency column. I have 2 scores. Then I'm going to add 4. So now I'm up to 6 scores. Then I'm going to add 7. So I'm up to 13 scores. I'm going to add 10. I'm up to 23 scores. So remember, I wanted the 20th and the 21st score. So that means that our 20th and 21st score are going to be in this section here. And if we go across, that gives us the 40 to 44 group. So our median is the group of 40 to 44 millimeters, or you can write the class center or the group center, which is 42 millimeters. Okay, now it says find the modal class. So remember, the modal class is the one with the most frequency. So if we have a look at our classes, the one with the most frequency is going to be the same group anyway, because they've got a frequency of 10. So 40 to 44 is going to be our one again. So 40 to 44 millimeters is our modal class. Okay. Over the page. Now, we've got a weird graph here and we need to be able to read what the graph says. So let's have a look at the information first. First of all, on the y-axis, I can see we're looking at percentages. Then we've got main source of income down here. So the blue part is employee income. The dark blue part, unincorporated business income. Orange is government pension and allowances, and the brown is other income. So let's see what they've given us. The above graph shows the percentage of the Australian population source of income for the year 2020. The population of Australia in 2020 was 25,727,066, with 18,231,231 earning an income. How many of the 18,230,100 people earned an income from government pensions and allowances? So let's have a look. Government pensions and allowances is the orangey one. And you can see up here on the graph, it's this section here, and it tells us 23. Now, 23 what? Well, if you go over to the left-hand side, don't forget that it told us it was 23%. So down here, we're going to take our 18,230,100 people and we'll multiply that by 0.23, which is our 23% of them being government pensions and allowances. So we multiply that and we end up with 4,192,923 people. Okay. Then it says what percentage of the population were income earners. Well, that's going to be the 18 million out of the 25 million. So let's write that out. So we would go 18,230,100 out of 25,727,066, and we're going to multiply that by 100 to make that a percentage. So you get 70859 blah 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 blah. So we might just round it to 2 decimals and go 70.86%. Okay, and now if it doesn't tell you how many decimals to round it to, just do 1 or 2. That should be fine. All right, now we have a Pareto chart here. So let's look at this one. It says a shirt manufacturer asked customers to fill in a survey asking their main reason for dissatisfaction with their purchase. The feedback was organized into the following Pareto chart. So we've got our frequency. So we've got button defects, pocket defects. Let's have a look. Button defects, pocket, collar, cuff, sleeve, cumulative percentage on the right hand side, frequency on the left hand side. So let's see what the question's asking us to do. If the manufacturer addresses the button and pocket defect problems, what percentage of customers would have their main reasons addressed? Now, the first thing I would do with any Pareto chart, because it's always about the percentages, I would go and look at my percentages. So the easiest way to work out which percentage is related to which one is to go from the left to the right. No, from the right to the left, sorry. So we're always going to end up at 100%, okay? Let me just move that out of the way. So here, this one's 100%. Now, if we go back to to the previous one, halfway through the one before, then this distance, this difference between our percentages, so if you go across here to these percentages, now these ones are not super accurate. This one's 100% take away. Well, I reckon that's probably around 95%, we'll say. So if that's the case, I would go, this one here is 100%, take away 95%. So I reckon this one's around, 5%. Okay. Then if we go to the next one, we're going to go to the middle of the next one, which is about there. And if we go across, we're looking, I reckon, at about 82 maybe. So this one here would then be 95% take away 82%. So we're looking at around 13% for this one. Then let's go to the next one. So again, we're going to the dot where it's in the middle, go across to the left. And I think here we're looking at about 65%, I reckon. So then 82%, the one above it, take away 65%. And in this one here, we'd be looking at about 17%. Then let's look at the next one. Let me find another colour. Okay, so this one's then going to go down to the first point, and we'll go across. And I think we're looking at 40% there. So we'd go 65%, take away 40%. So this one in here would be looking at 25%. And this one, the first one, is going to be just whatever that value was that we just found then. So you'd be looking at, say, this one here is going to be your 40%. Now, if you add all of those up, they will add up to our 100%. And now from there, we can answer any question. So it says, if the manufacturer addresses the button and pocket defect problems, what percentage of customers would have their main reason addressed? Well, if we're looking at button defect and pocket defect, that means we want the 40% and the 25%. So I would go like this. 40 plus 25 will give me 65%. The next one says, which additional defects would they need to address to ensure they were meeting the needs of 95% of their customers? Well, 95% of their customers is going to be all of these ones, isn't it? Because this last one here is the 5%. So far we've done button and pocket, so we would need to add collar and cuff as well. So you would write collar and cuff defect. Okay, so see how it didn't take very long to do the part at the start, getting all the different percentages, and it means it just makes it easier to answer the questions. Okay, 2 more to go. So Georgia deposits $10,000 into a high investing savings account that earns an interest rate of 5% per annum So we've got 10,000, 5% per annum compounded yearly. That's nice. If she leaves it there for 5 years. So everything's in years. We've got per annum, yearly, and years. So we don't have to change anything. Calculate the amount of interest earned at the end of the first year. Well, if it's just 1 year, then we just need to find 5% of the $10,000, don't we? So we would go 10,000 times by 0.05. So for 1 year, she's going to get $500. Now, it says here, use the table below to calculate the amount the investment is worth over the 5 years. Well, in the first year, she earns 0 interest, doesn't she? Okay, so let's have a look. In 0 years, it's 0 interest. That's how much she puts in. So the first year we just worked out it was $500. So now she has $10,500. Now remember, this is compounding. So it means the next amount of interest is on the $10,500. So we would go 10,500 multiplied by our 5%, 0.05. And the new interest for this year is going to be $525. So now we add that to our 10,500 and we end up with $11,025. Now that becomes our new amount. So if we go $11,025 and we multiply that by our 0.05%, and we get $551.25, because remember, this is compounding, so it means it's going to go up every year. So we get $11,576.25. Take that amount, 576.25, times it by 0.05, and we end up with 578.81. Now, when you put this into your calculator, it gets pretty easy because you just leave it in your calculator and keep calculating. So once we get this answer, you then just times that by 0.05. I'm just writing it out. I'll show you what you need in a sec. The last one is $607.75. And if we add that, we end up with $12,762.81. So for your test, you don't need all of this calculation here. You just need to show that interest and then the total amount. I was just showing you how we got the interest. Okay, then it says, how much more would she have in the account if the rate of 5% was compounded monthly? Okay, so this is where we need to make a change. So because she is in there for 5 years and the 5% was per annum, so we need to then change our time period, N, 5 years times monthly, so we get 60 compounding periods. And our rate is going to be 0.05%, but we're going to divide that by 12, okay? So remember, if it's changing, so the monthly means that we have to change it. Now, we're going to use our future value because we're doing it for 5 years. So our future value, remember, is on your formula sheet. It's FV equals PV bracket 1 plus R to the N. And we can just put our information in. So our PV was $10,000 times by 1 plus our rate for the month is 0.05 over 12. And we're doing it for 60 months. So our future value, if it was compounding monthly, will come out at $12,833.59. And then the question says, how much more would she have? So we need to do a subtraction. So we're saying that she's going to get 12,833.59. From our previous question, she got 12,762.81. That's when we compounded yearly. And our difference comes out at $70.78. So she will earn $70.78 more compounding monthly. Okay, question 30. This is a bit of an odd question. A rectangle has a perimeter of 2 meters. If 5 centimeters is taken from the length and added to the width, the rectangle becomes a square. Show that the following equations could be used to model the situation. Okay, so this one here says 2 lengths plus 2 widths equals 200. Well, that makes sense, right? We can go width, width, length, length. That makes 200. That's a rectangle. So this one here you could say is already done. Then we've got one here that says L minus 5 equals W plus 5. So what they're saying is we're going to take away, so I'm going to draw, because it says here that this is going to turn into a square. So let's draw a square. And if we go L minus 5, so if we take away 5 from our L, here's our L minus 5, and then we add 5 to our W, and it tells us that they're equal. If these are equal, then it means it becomes a square, because if the width and the length are equal, then that means we have a square. Now, it's asking you, show that the following equations could be used to model the situation. Well, we've done that. So we've shown that 2 lengths, we've got 2 lengths plus 2 W's can equal 200. And we've shown that L minus 5 and W plus 5 are equal, which makes a square. It's a bit of an interesting question. It's logical thinking. And you have to use a bit of your maths logic to answer that question. So B part of this says find the side length of the square. Okay, so I'm going to take the information down here again. If I've got 2L plus 2W and that equals 200, then I've got L minus 5 equals W plus 5. Okay, and it wants me to find the length of the square. So the length of the square, remember that equals, we could use either of these. What I'm going to do is I'm going to rearrange this equation over here so that I can find the L or the W, and then I'm going to substitute it into this equation to find an answer. So let's change this. Let's plus 5 to both sides, and I end up with L equals W plus 10. Now, if L equals W plus 10, I'm going to take that and I'm going to insert it into this equation over here. So that means this one becomes 2 times W plus 10. So all I'm doing is substituting that in for the L, plus 2W equals 200. Now, if I expand this and simplify, I get 2W plus 20 plus 2W equals 200, which gives me 4W plus 20 equals 200. And now I've got a two-step equation. So I'm going to minus 20. So we get 4W equals 180 divided by 4. W is going to equal 45. Now they wanted me to do what is the length, didn't they? So from here, I'm then going to take, my width is 45. So my length of the square, the L, is going to be W plus 5. L minus 5 equals W plus 5. Now I know what my W is. So again, I can use the L equals W plus 10. So my length is going to be 45 plus 10, which will give me 55. Now you can check if this answer is correct because we now have an L and a W. So let's take it back to the rectangular part where it said 2L plus 2W equals 200. And we'll put our L and our W in there. So that would be 2 times 55 plus 2 times 45 equals 200, which is correct. Now, I just want to say that you will find, if you were looking at the actual solutions for this exam, that there are a couple of solutions that are actually incorrect. But I've checked all the solutions that I've given to you in this video and they are all correct. If you have any more questions, please see your teacher and they will be able to help you. Thank you.